we will be taking a closer look at negative exponents. We have looked at positive exponents, but we have yet to look at negative exponents. And so what is a negative exponent? Well, a negative exponent is something like x to the negative third power. And we're not quite sure what x to the negative third power means. We know that x to the third power, though, is x times x times x. And if we would multiply those two quantities, we would get, multiplying, we add the exponents, we would have x to the 0th power, and anything to the 0th power is 1. Well, if we know x to the third is x times x times x, and eventually we want this to be 1, then we need to divide that by x times x times x. So x to the negative third, the rule is that when x is being raised to a negative exponent, such as negative 3, we take the reciprocal of that and say this is 1 over x cubed. Let's take a closer look at that. So we can look at this rule one of two ways. We can say 1 over x raised to a negative power is the same as x raised to a positive power. The other way we can say that is if x started off by raising to a negative power, that equals the reciprocal of 1 over x to that positive power. And you can see that happening here. X is raised to a negative power, and then the reciprocal is 1 over that. And something then in that denominator raised to a negative power moves to the numerator. So the other way to think of that is that a numerator with a negative power moves to the denominator, and an exponent in the denominator with a negative power moves to the numerator. That's what we are showing in this example. 3 to the negative second in the numerator comes down to the denominator as 3 to the positive second, and 5 to the negative fourth in the denominator moves up to the numerator. If we have some sort of fraction, x over y, all being raised to a negative power, we can look at that as the reciprocal, y over x, raised to the positive power. This is explained in a little more detail. X over 3 raised to the negative 5th power. You can use some different rules to understand this. The first would say distribute that negative 5 to get x to the negative 5th over 3 to the negative 5th. And then we know that anything with a negative exponential power, we take the reciprocal, or numerator moves to denominator, denominator moves to numerator. And we could rewrite it in this last form if we wanted to. So in simplifying negative exponents, we are going to look at this expression here and note that we only want to write a positive exponential power at the end. So we start with 5x to the negative fourth, y to the negative third, times z to the 5th. Now, using order of operations, we remember that parentheses comes first. And inside of my parentheses, I have exponents that I need to simplify. So I'm going to start by rewriting this expression with using only positive exponents. 5 stays in the numerator because 5 is not being raised to any power. X to the negative fourth, though, must move to the denominator as x to the positive fourth. Y to the negative third will also move to the denominator as y to the positive third, and z to the 5th stays in the numerator. This new fraction is being raised to the negative 2nd power. I'm going to now take the rule that says when I raise a fraction to a negative power, I take the reciprocal of that fraction and raise it to the positive power. So this becomes x to the 4th, y to the 3rd in the numerator, divided by 5, z to the 5th in the denominator, all raised to the positive second power. And now I can distribute that second power to everything in this exponent. X to the 4th squared, power to a power we multiply, getting x to the 8th. Y to the 3rd squared would be y to the 6th, divided by 5 squared. I'm going to write that already as 25. And z to the 5th squared, power to a power I multiply, z to the 10th. And that would be the simplified form.